Welcome, and thank you for joining us for our webinar. Today we'll be talking about using the programming language R for data management. My name is Terry Bowler, and I will be your host. This webinar will take approximately 60 minutes, with the last 30 minutes reserved for questions and answers. This webinar is designed to be interactive to help you understand the content better, so we will ask you questions with polls throughout the webinar. We encourage you to ask questions by clicking on the chat icon at the bottom of the screen. You will be able to preview and enter questions at any point during the presentation. Your questions will be answered during Q&A at the end of Q&A session at the end. All participants are on a listen-only mode. This webinar is hosted by Emanate Life Sciences. We are your clinical data management resource. Our services include data management advisory, data management functional service provider, and contract permanent placement services. What makes Emanate unique is that we share our data management expertise and knowledge to help you succeed. For example, with our placement services, you will need not to screen through stacks of applicants. We'll send you a very few high quality candidates to choose from. We have a robust screening process that includes a data management expert interviewing each candidate for technical skills, and this allows us to deliver high quality candidates right at the start of the sourcing process. To learn more, visit our website at www.emanatelifesciences.com. I'd like to introduce our presenter for today, Eric Morrie. Eric is currently Associate Director of Data Management at Veracyte, managing clinical, biospecimen, and assay data for diagnostic development. Prior to joining Veracyte, he worked for ClinCapture, a Bay Area EDC provider, responsible study build and data management services. He previously worked at Winseer, Onyx Pharmaceuticals, Abbott Vascular, and Bausch & Lomb, providing process and technology implementation for clinical operations, data management, regulatory affairs, and global product safety. His expertise in academic research and healthcare in the University of Rochester Medical Center utilize diverse technologies and specialized programming. Eric has worked in healthcare, pharmaceutical, and medical device industry for over 20 years. He has a master's in business administration and a bachelor's in engineering science from the University of Rochester. Eric, if you'd like to begin the presentation.
Thank you, everyone, for joining us today. We're going to do a quick poll to get started. So if, Terry, if you could just initiate the poll, please. So we want to get a little idea of what everyone's experience with R is and maybe some of their interest in coming to join this session. So go ahead and click on the choice that best represents your experience and with R in your own organization or maybe in your own career. All right, looks like we're coming up on the end of our 30 seconds, so they'll end the poll here momentarily. Okay, so you can see from the results that about half the people know what R is, but they don't use it. Some people are using it right now, and some have not heard of it. And so this will be hopefully something that everybody will be able to learn a little bit of stuff new from as we go through today's session. So go ahead and we'll stop the poll there. And let me just jump back into the slides. So thank you everyone for joining us today. I'm going to go through, as Terry mentioned, my experience with coming from larger commercial organizations and coming into Veracyte, where we didn't use SAS here as an organization. Typically, we use R as a programming language. And overseeing the data management team here, we were using a lot of Excel-based files, using an EDC system or a couple of EDC systems to collect site data, and then figuring out how we're going to actually get those data sets ready for the data analysis team. So I want to share with you the process we went through in data management to make sure we had all of our ducks in a row to be able to use R here at Verisight. So why is R attractive for companies to be looking at? Well, the first and foremost is R is a scientific and statistical language first and foremost. That's its bread and butter. That's what it's built for. It has very powerful regression capabilities. It's designed for reproducible research. So the fact that you can record and script out all of your research design, including any descriptive notes and comments about your research, can all be rolled into the same package of code. It's focused mostly on ad hoc analysis and data exploration. So if you are looking to query things and align things up and compare, it's a great tool for that. The other big thing about R is that it has earlier adoption of the latest techniques. In a little bit, we're going to show you a comparison with some SAS functionality. But in this case, because it's used heavily in exploratory research, there's often earlier adoption of those newer techniques that may be used for big data or large data processing applications. And because it does have an open source component, there are regular contributions to the community of what are called packages. There are currently over 13,000 extension packages that you can get for R, depending on your needs. Those can be freely available, or some of them can be purchased. But it's important to note that R does have both an open source component as well as a paid support application. So you can use R freely within your organization, or you can purchase R services from a number of companies that offer them for life sciences. So it has the best of getting started, doing a little bit of exploration when you need to, but you can expand that into a fully supported environment with servers and clusters if you need to process large volumes of data. Now, I've talked about some of those packages, and I want to share a few of those here. These are the packages that in the data management team we have identified as packages that help us deliver our activities. And don't worry, this webinar is being recorded. It will be shared later, so you don't have to rush and scribble these down. You can always look at this list later. But I've broken them up into 4 areas: input and output, utilities, data transformation, and graphing and layout. So those are the 4 areas where R is going to be able to support the data needs of a particular data management team. And these packages are available on the R community download sites if you want to download those and use them in your own R implementation. Now, you may be asking yourself, can I really use R in clinical trials? And the answer is yes. In fact, a recent survey has shown that it's the 2nd most preferred language in clinical research, SAS, of course, being the first. And Python is making quick advances. So the Python language is actually almost up to the level of R. And again, Python is good for a lot of that big data and high volume genetic data, depending on your activities. Now, what's interesting about the survey that was done by Birchworks, you'll also see that years of experience correlates very well to the language as well. Some of us that have been in the industry for longer use SAS more often, whereas Python is one of the newer technologies that are used by people that may have bridged into life sciences from other organizations, because Python may be more popular and is also being taught in a lot of college courses now for data science. So again, you'll see that probably becoming more popular as well. Now, the FDA does not endorse or require any specific software. They do require that you validate that that software is fit for purpose. So you can use R in your environment if you would like to do that. And in fact, the FDA uses R in combination with SAS on a daily basis. So they actually have R applications within the FDA that they use for data exploration and analysis. And the FDA has actually contributed some R packages back to the community. And for those of you that may say, well, validating software, what do I have to do for that? Well, you don't have to go that alone. There is an R document provided by the R Foundation that helps you walk through the validation steps that they follow to make sure that the package, the base application and the packages are validated to work together. You would be responsible for validating any of the specific packages that you may incorporate into your workflows. Some of those I noted earlier on the packages slide. Once you've tested those that they work, you don't have to do that over and over. You want to sort of set up your library of standard packages and make sure that they work in your environment, but then you'll be able to use those no different than if you were using SAS as your data transformation platform. Now, I mentioned I'm going to do a little bit of comparison between SAS and R, and that's here on this slide. And there are some things that you should be aware of if you're going to use R in your environment and you come from a SAS environment like I did. The first one is that there's a difference between the languages between SAS and R. SAS is a high-level data manipulation language, whereas R is a lower-level object-oriented language, so it aligns more with your C++ or your C# or Java type languages, whereas SAS aligns more with like a SQL language or some sort of meta language like PL SQL from Oracle, where you're doing data selection and data manipulation activities. Now, they both do have statistical components, and those are both readily available in both packages in both languages as well, but you have a deeper access to the underlying language using R. In terms of data handling, both of them handle all of the same types of data files or data handling scenarios. You can use flat files, you can access SQL databases directly, you can read web services, you can look at data lakes. Any of those things that you need to do can be done in either platform. Now, one of the big things to keep in mind between SAS and R is in terms of the data processing capabilities. SAS is a file-based processing tool, meaning it reads a record from a file, processes that record, and puts that record out to the new file. Whereas R is an in-memory processing engine. Now, you get some speed benefits, but it also means you have to have a lot of memory to load very large files. And that's why you might see R used in combination with something like Python, which is more of a file-based processing language. You might have R calls to Python, and then Python does the large, heavy lifting of the big files, and then your results will be brought back into R. Now, statistical capabilities, there are some limits here. SAS uses a lot of vetted methods. So there are a lot of things in SAS that are completely vetted out, and they aren't included in the SAS package unless SAS themselves have incorporated that there. Whereas R, because of its open nature, a lot of people can introduce leading edge techniques and test those techniques there even before we may see them in SAS. So if you are doing things that are more unique, you will have to, you may want to use R so that you can try out some of those unique techniques. In terms of the interface, very similar between the two. There's a command line interface if you're tying this into some other application you have internally. There's a local GUI that you can run on your laptop or your workstation. And then there's a server model where you can run a single server, or you can run in clusters. We run clusters here in order to process large volumes of data. So any of those options are available from SAS or from R. And in terms of outputs, we all are familiar probably with the SAS formatted outputs. They look like stick figure graphs usually. There is SAS Graph, which is getting better at the outputs, but R really excels in this area. It has manuscript ready layouts. So you can actually produce manuscript ready documents right as part of your R processing. So you don't have to take those into Word. You can actually generate directly into Word format from your R code if you'd like to do that. So there are 5 things that we're going to talk about here in the next few slides that really relate to how you're going to use R in your environment. And the first one of those is the programming interface. R, as I mentioned, is one of many languages that you could use. You could use Python, you could be using SAS. The nice thing about R is it's supported in a number of graphical interfaces. So they are not the only, R is not the only interface. There are lots of tools. For example, Jupyter Notebook allows you to run R, Python, and Scala code all within the same interface. So if you're familiar with using those other 2 tools, the interface will look very familiar to you if you start using R. In addition, there's the R tools for Microsoft Visual Studio. So if you are a Microsoft shop using Office and C++ or Java, or J# or Java Sharp, you can get the add-in for Microsoft Visual Studio, and this will allow you to run R alongside other Microsoft languages. And again, use a common interface that your teams may be familiar with. For me, I like to use RStudio. RStudio is a dedicated environment to R. It has package management built in, so I can control the packages that are available in my RStudio implementation. It also supports the R Markdown and Shiny packages, which allow you to create, as I mentioned, R Markdown is for manuscript-ready layouts, and then Shiny is for web presentation if you wanted to present things on the web. So both of those functionalities are built into the RStudio, which gives you a little bit of better visibility to your whole suite if you are using page layouts or you are using web-based layouts. You can see those right in the application. Now, once you've selected your programming interface, and any of those will work, and you could go old school and use a text-based editor, those will work as well. But the first thing you're going to learn in R, and this is the first thing that we basically do with SAS, is data transformations, right? We've got to get data into the system. So we read data from many sources. In R, that includes SAS transport as well as SAS BDAT files among Excel, CSV. I can read directly out of the database. I can read web service calls. If I had SOAP data or I had a JSON file, I can read those directly into the R program that I've written. You will then want to learn about deriving and imputing new variables. So again, this is going to be where you create a calculation, or you have to fill a variable if you don't have a variable already created. You'll look at assigning categories to continuous data. So this is data bucketing. In R, you're going to call these factors. So they're basically discrete lists or buckets. Maybe there are visits in your study, or they may be sex of the patient, male and female. Any of those categorical variables, you're going to want to make sure you define those categories assigned to the data. Especially if it thinks it's continuous, if you're using ones and zeros, a lot of times Excel or other tools will look at those as being numeric values, and you want to make sure you assign those categories. And I'm going to show you a little demo of some of this stuff in a little bit. Pivoting data, including text. So a lot of us struggle in Excel with trying to get data into a pivot table because Excel naturally wants to calculate everything that's in the grid area. So you got rows and columns, but it wants numerical values for the grid. Now you can create a VB function that allows you to do that and substitute those values back. But in R, it's very easy to pivot text data into rows and columns. So maybe I want to create a schedule of subjects down the left and visits across the top, and I want the word completed or incomplete to be displayed in my grid. I can certainly do that using the pivot functions in R. If, then, and else, just like in SAS, we have a number of options for if, then, else, as well as case or select statements where you can select conditionals. Another nice feature is the summary statistics. So, looks like we got some background noise there. Let's see if we can mute that. Okay, I think we've got it muted. So summary statistics. So this is a very powerful thing. I call it DTD here at Verisight, data type definition file. I generate this with every data set that I send. It actually gives you a listing of all the variables. If they're continuous, you get the means and the averages. If they're discrete values, I get counts of how many fall into each category. I get how many missing values there might be. So it's very powerful to have those DTD type statistics about any data set that I may be working with as I pass it on to another group who may receive that file. And then the last thing is creating custom functions. So you can actually create a custom function in the R package that is for your organization. This is different than packages. These are functions within your code. You can set them up as macros like you would be used to in Excel. So once we've done our interface and we've got some data transformation, we then can start to visualize our data. And when we visualize data, we're going to visualize that into graphics of some sort. There are a large number of add-in packages for R that cover all sorts of amazing graphics that people have produced using R. You can see some of those here on my slide. The output format that you select, however, must match what your rendering is. So if you're going to be using these for PDFs, you want to use, or if you're going to be using these for print outputs, you're going to want to output to PDF. If you're going to be using them for the web, you're going to want to output to PNG. And if you use R Markdown, you can really, the R Markdown engine will actually make those adjustments on the fly. So you can generate once with PDF, generate once for web, or print and then web, and have the same look and feel between those different layouts. And these are some of the extensions that I've listed here for visualizations. ggplot and Plotly are two very common used packages. You have the Sunburst package. This allows you to create pie charts essentially that have like rings around them. If you want to have rings that of larger wedges of the pie as the rings go out, sort of like the rings of a tree, you can slice those rings up separately within the package. And then there's another product called, a package called HighCharter. It's not used for printed graphs, it's used for web-based graphs. And this is good because it has selectable capabilities. So you can zoom in or out on your X and Y axis. You can select certain data points within the chart in order to reference data in like a associated table. So it works a lot like some of the things you may be familiar with in Comprehend or Spotfire. You can create interactive charts where when the user selects something in one chart, that can be related to other data elements in your web browser or in your PDF. So again, these add-on or packages certainly do help you produce the graphs. And Plotly and ggplot are the very standard ones that'll be in R, but you can add others for Sunburst or those interactive graphs. But that's where you're going to really start to visualize the data, and the amount of visualization you can do is really unlimited. You can see here I've got three distinct styles of graphs. I've got side-by-side charts with bars, blocks, and whiskers, and the data in there. And I've got three of those side-by-side representing, three different aspects or facets of that data. Maybe I'm comparing, January, February, and March performance across. In the middle one here, you've got this sort of radial pattern that looks like some in the lower left quadrant are certainly at a higher percentage. You can't quite make out these rings here, but you'll see that there are rings of percentage that represent the radial, and then there's directions north, east, south, and west that indicate direction, but you could use these for any quadrant-based layout. And then, of course, this was that ring chart I was mentioning where the inner ring has a normal pie, and then each subsequent ring slices up the aspects of that pie wedge to get to finer and finer granular detail in that presentation. In addition to formatting graphs, you can of course have page layouts or formatted layouts. This is accomplished with R Markdown. It includes the ability to have cover pages and table of contents. You can produce this in Word, PDF, rich text, any number of available output formats. You can also change the page layout in mid-document. So I can have a landscape page, and then I need to flip my page to portrait in order to have more room for a taller graph or something. I can flip page dimensions midline as I'm generating my PDF. Custom headers and footers are fully supported. I can include text, tables, and charts all within the same document. And then I can also use this for what I call burst distribution. If you don't know what that means, it's called mail merge. So those of you that have never heard of burst distribution, it's basically mail merge. I can generate one document per site for all the sites that I have data, and I can email that site-specific document to the user's email address that may have been stored in the data. So I can have a very unified format, and I can generate those reports on a burst basis to allow only the data for that site to go to that site. So you can do these burst distributions with these kind of documents. We also use them here for patient profiles. So we have a very standard format for our clinical summary or patient profile. And what we do is we'll output those clinical summaries, one per patient, and we just run output for the program, and it generates a document for each subject individually. So again, formatted layouts, great for patient profiles, great for site metric reports that you're going to be sending out to the sites, but you can also use them for a fully formatted, publication ready kind of manuscript if you wanted to do that. And then the last thing you'll see a little bit today is going to be some analytics stuff. So in the R suite, there's a tool called Shiny. Shiny is the web-based interface that you can share with the data users. So these are not the person programming the report. These are the people that are going to consume that report. And those data users, you can use Shiny to produce dashboards. You can give them data exploration windows. You can allow them to upload a data file. So maybe part of your R code is to take a file in from the user, include that as part of the analysis, and push back a report. You can allow them to do that, to submit those files if those are one-off files. We use this for things like panel review, or if they're coding certain active data, so they're going to get a download, they're going to code those things. Maybe they got to read the comments field and flag any issues related to what was written in comments, and then they can upload that file back in to be used as part of the input. And then you can also allow them to download those reports. And this allows web browser access, so they have to have a web browser. The graphs will refresh automatically as new data is available. And it does support data selection and filtering. So if you want to give the users the ability to slice and dice data that's in that report, you can do that. And we'll see some of that today as part of the demo. All right, and again, if there are questions, feel free to enter the questions in the chat box by clicking the chat button at the bottom of the screen. So if you hover your mouse toward the bottom, you will see the chat box indicator. I did include some references here, and as I mentioned earlier, this session is recorded and will be shared after the presentation is finished. So you'll be able to come back in and find these. You don't need to quickly scribble them down. But I did provide the information from Janice Brodsky about the use of R at the FDA and the FDA's take on such documents or use of such products. I've also included the information about the R project document for validation of R here in the references. And then a couple of things on the cheat sheets. So there's a number of groups that make cheat sheets available. They're like one page front and back that you can laminate and throw on your desk or stick on a board at your office, that as you're getting going, that's a great thing to use because it highlights a lot of the common features and syntax that you might need to be familiar of while you create some of these R programs. All right, so I think we're going to do the second poll. And so Haj will hopefully start that here momentarily. Oh, there it goes. Here's the poll. So how are you considering the use of R? So what are your thoughts about using R in your organization? Is it something that you may use, may not use, have no interest in? But we'll see what comes up here. All right, so it looks like we're getting some feedback. We usually go about 30 seconds. And we got a good feedback. So Haj will end this here momentarily, and then we'll show the results. So the big thing here is I need tools for dashboards and outputs. Well, that's great because I'm going to show you a dashboard that I created, and we'll talk a little bit about that here in the demo. But it's also good for exploration of data if you need to do that, and I'll talk to you a little bit about why that might be a good thing to use for R as you begin to explore things. So let's go ahead and jump into the demo. I'm going to stop sharing the screen here, and I'm going to share my screen. And let's see what we got here. Screen 2, I think, is the one I want to share. Let's see. All right, so you should be seeing my RStudio screen. Hopefully, let me just bring up the participant info real quick and make sure. If you can't see the R screen, the RStudio screen, somebody let me know, but I think we're in good shape. All right, so the RStudio screen is, okay. And I didn't see any questions yet, but if we do have questions, feel free to enter them in the chat box. Again, if you're not seeing the chat box, you might need to click on the top of the screen and say exit full screen window. Sometimes you can't find the chat button on certain machines, like the chat window doesn't pop up if you're in full screen mode. So if you aren't seeing the chat window, go ahead and exit full screen. So there'll be a little thing that says exit full screen, and then you'll be able to enter questions into the chat box. So I'm going to take you through a simple program real quick, and don't read too much into this. This was put together just to illustrate what we do and some of the things I like about using R as a tool. One of the first things you're going to see, these are those packages that I mentioned. So these packages are in use in this program. So you call the packages you need to use as part of that program. HMISC gives me a lot of SAS equivalent functions, so I include that one. ODBC I can use to connect directly to databases to grab data. I don't have to get it from a flat file. Dplyr and reshape allows me to do data transformations. OpenXLS X allows me to open Excel, read and write Excel files. Keyring allows me to encrypt passwords. So for example, I send email in my program. So I am encrypting the password using Keyring. And then Mailer allows me to send an email message with attachments. So I actually send, when the program runs, I'll send a PDF with that information attached. So when my program runs in the middle of the night, I don't have to be up to mail that to the person. I can actually send that to them. One of the things I wanted to point out was this global function here. This allows me to create a set of functions that can be used across applications or across programs. The only thing I have in there right now is this function over here on the right-hand side of my screen called most recent file, and it's a function that takes a directory path and part of a file name, and it returns the most recently dated item in there. So you'll see here, it's now popped up on my screen with what happens. It actually runs a file info command. It gets me a list of files, and then it narrows it down to the whichever has the maximum time, meaning the most recent file, and it returns the whole file name with directory to me. So if I am getting regular downloads from a laboratory vendor or from an EDC system, I can run that function and always grab the most recent file that's in that directory. I don't have to change my program every night to grab a new dated file if they append the date onto the file in some fashion. Now, if they overwrite the last file, you of course don't necessarily need this. One of the nice things I like about our studio specifically is when I create a data set, which is or I transform a data set, it creates a running entry here on my upper right corner of those data transformations. So you can see I started here with subject summary, which went out and got our Medrio data file. So it's a Medrio standard report, and it brought in 15 variables. I then added a field here in order to capture the site, to separate the site value off for the site number from the site name. So I've separated that off, and that gave me 16 variables. And now if I come down here, I'm going to subset that data for only the demo study. So I'm going to run that again. And you'll see now here in the right-hand corner, I got a new entry called result with 16,000 rows instead of 26,000 rows. So at each step in my process, I'll actually be able to review what data is being filtered down based on the conditions or the filters that I've applied to that program. And then here I'm going to do some mutation, I'm going to do some subsetting, and I'm going to do some tallying. You see I mentioned that word called factor. So in this case, I'm telling it that the factors belong in a certain order. So screening, enrollment, visit 1, 3, 6, 12, 1 year, 24 year month, 2 year, through 36 month, malignancy termination and tissue consent, and then our Verasite use only. So you'll see here that when I run that, it will actually make those in the right order for that particular categorical variable. And you'll also see now in the upper right hand corner that my result has narrowed itself down. So if I click on that, you'll now see I have the result data, and I can actually review that data, and am I getting what I'm looking for? In this case, I've got 4 entries for screening, and then my form status column is complete, incomplete, locked, or missing, and that's 1,201 missing, 43, 14, and 4. And then maybe I want to graph that. So I'm going to use ggplot here, and I'm going to actually run a graph of that. And you'll see in the lower right-hand corner, I actually get a snapshot of my graph. So I can preview all of this as I work right within the interface. And once I determine all of these things look the way I want them, I can then choose to output those into a PDF if I want to do that. In this case, I've done a stacked bar chart with count of forms by status, and I've got the visits stacked up here along the left edge of my screen, or left edge of the chart here in the lower right area of my screen. Now last, I can export to Excel. If I was putting out a worksheet of data, I can actually create multiple worksheets. I can export data to a worksheet, and then I can write that file out. As I mentioned, here's where I generate that DTD document. So this actually is going to capture the details about that particular file, all the variables in there, all of the information that's available in there. That'll be captured in my DTD. And this is my little email code that allows me to grab those attachments and actually send those attachments through our mail server, so I don't have to be up in the middle of the night when the report runs to make sure the study team gets that. So all of that can be automated. It's very similar to what we have always historically been able to do in SAS, but this allows me to do these presentation level graphics, very easy, very visual. And if any of you have worked with SAS Graph, you know that that tends to be a painful thing to do because you don't have this preview capability to know, okay, if I tweak something, what is it going to look like, right? If I go back up to my graph and I say, I want that to say form count, I'm going to just change this here real quick. I'm going to highlight my code, and I'm going to run a quick preview of that. And now you'll see at the bottom here, right, it says form count instead of count of forms. So again, you get those quick previews right within the interface for anything that you may need to do. Now, that's all good for assembling stuff for a report that you're going to put out as a PDF, but what if I want a dashboard, or what if I want something else to present to my users? So in that case, I'm going to run a Shiny app. So this is an app that takes a lot of that stuff you just saw, and it's going to present it into a web browser so the user can access that. I'm going to click run. My app is already set up. It's going to pop up my web browser here in just a second, and it's going to give me my dashboard. So this is my dashboard, and there's only one trick to this dashboard, which I didn't show you today, and that is we have a nightly job that picks up standard reports from Medrio and from our other EDC provider, and pulls those down, and then it concatenates them together. So it just appends those standard reports together in order to produce this dashboard. But the nice thing about it here is on the left, all of the studies that we have running are summarized together. So I can see a snapshot of all of my data for all of my studies, but I can also filter for a specific study. So watch the numbers in the top blue boxes as I click on demo. You'll see that these numbers change, and then you'll see that these graphs here refresh down below to represent only the portion of the data related to the demo study. If I change this from demo to collab, this will also reset the numbers and show you just the data related to that one study. And if I wanted to drill down further, I can actually drill down to a particular site. So let's say I pick Hospital 308. You can see enrolled subjects, incomplete, missing ECRFs, how many open queries, what their query rate is, any form status down here in the bottom left, and open queries by visit in the bottom right. And again, if I pick some other study or some other hospital, I'll get a different set of numbers. And so the team can actually review this on an ongoing basis to see how those sites are doing from the dashboard. Now, again, this dashboard took me about 3 days to build. So I did create this dashboard specifically for the demo because I wanted to highlight some other things in here as well. So the other thing I added was a download. So if you click on download to PDF, I can do that. So I'm going to click download to PDF. That'll actually download the data that I see on the screen, and you'll be able to get a PDF here momentarily as soon as that runs. I think it's downloading. There it goes. It's downloading. Let me open that PDF real quick so you can see that. So here's an example of using the page layout, and I wanted to download that data. So now I have a list of all the enrollments by site because I selected all the sites for this particular study. I have a count of my CRFs. I have open queries by visit, and then I have 2 charts. And again, these charts can be colored differently than your other charts if you want to do that, or you can match them up and make them look the same. But I included them in the output so that you'd have them as part of the download. So if you do want to take it offline, you can do that right from the dashboard. And then in addition, if I want to see what makes up one of these little colored bars, I can actually click on that bar, and then you'll see the underlying data related to that. So because that data is all stored in the system, you'll actually be able to see what data was associated with that. So here you can see this is specific subject, subject 301, and I'm going to actually expand this to 100 entries here real quick. So once I've clicked on that little bar, I can display a table of data. And what I display in this, of course, is up to the programmer who creates this dashboard to decide what to display. If you want to display all of these variables. And there are some, there's a website called shiny.io, I think it's called, where there are lots of demos of things that people have created in Shiny that they use. And one of them, you can actually let the user select which columns they would like to display. So once you get to this page, you can have a little menu up here and you say, okay, I want to just see these columns of my data. And you can give them a little bit more flexibility in customizing those columns. And then you can also give them a download button here to download to Excel. Instead of downloading the PDF, you might want to download this information to Excel. So again, it all depends on what you put in your dashboard that you want to make available to the users as to what they will have access to and what they can see. But again, the big thing is it's pretty quick and easy to make a dashboard. The getting the data behind it from whatever systems that you have will really make a difference, right? So if you've got access to an open system that allows you to pull data via web services like Rave or Medrio or others, maybe they got a REST interface or something like that, or you're downloading static reports every night and you're just putting those in a folder, the dashboard can run off of that as well. So all of those are options. So I can either rely on the files, the standard reports from my EDC vendors, or you can jump into web services and you can grab that data directly via the web service. Anytime that somebody runs the dashboard, it'll go out and make a web call to get that data if you've got that feature from your EDC provider. So again, number of options for getting this data. We use the files just because they were currently available and we were downloading them anyway. So it was very easy for us to get our dashboard set up on top of that because we already had an application that was picking up the files on a nightly basis, our standard reports on a nightly basis. So we just built off of that. But if you did need to go directly against the web services, R fully supports that if you wanted to hit the EDC vendor directly rather than being a nightly batch job to get those refreshed metrics. All right, I'm going to hand it back over to Haj and Terry, and we'll take questions, I believe is the next thing on the agenda.
Yes, thank you, Eric, for the valuable information regarding the lessons, transitioning, and the demo. That was really great. As you said, at this point, we're going to remind you to use the chat icon at the bottom of the screen. We do have questions coming in right now, which is great. We'll do our best to answer all the questions in the designated time. However, there may be more questions than we have time for, and as we have said, the webinar has been recorded, and you can access the entire presentation and questions at Emanate Life Sciences website. So let's start with the first question. I am confirming that the presentation will be available after the session. That was one of our first questions. So it looks like, is there no need to use any other reporting interface with R? Is that correct?
That is correct. So you can use R for everything from your data transformation to your graph production in your layouts, like in a PDF, right through to having a interactive web. All of those are features built in R. I didn't use any other tool. Everything I use is R application based. So it's R Markdown, and Shiny are the three components of R that I'm using.
Okay. Are you able to connect R to metadata Rave web services to pull data from dashboard/report generation?
We don't use metadata here, so I haven't tried that yet. I am in the process. As I mentioned, we do have a nightly job already with our EDC providers to pull the standard reports off their server and put them in a directory. So right now we've built off of that, but I am playing with the web services components to see how I could pull that data from the web service component that's available with our EDC provider. If there's a web service component for metadata, you get the data. The question is, are you getting the right data? Absolutely, I'm 100% certain I can connect to the web service and get that data back. It's just figuring out how I'm going to present that data when I pull it back. And I don't think it would matter whether it was Rave or Medrio. I think the web service will present the data I need. I just need to get that data in a format that I can process. Let's see, there was another question. Got it. So that one was answered. The one about showing what data is missing or data makes up those things. Yes, if you set up your dashboard that way, you can click on the graphs and charts to drill down to the actual data, as long as that actual data that you want to display is available somewhere to the R application, whether it's through a web service or it's available in a CSV or flat file. You can, of course, display that data to the user.
Okay, Eric, great. What is the average time that it takes a person to be trained in R that has never used it before?
Good question. So I had never really used R until I started here. And that was July 15th. I got a crash course of about a day's worth of training to start using it. Because I was familiar with SAS, it was very straightforward. The parallels between R and SAS are very similar. I had to learn a little bit new terminology. They may call things something a little bit different than I was used to with SAS, but all of the functionality that I had available to me in SAS exists in R. And because R is such an open community, I just went to Google every time I needed something, and it would be, oh, you're looking for this thing, this function name. And once I looked up the help document for the function, I was able to see, oh, okay, now I understand what goes where. The cheat sheets are great in terms of having all the most commonly used functions that you need for each, for R Markdown, and Shiny. Those are great tools to use as the cheat sheets. In terms of hours, I didn't really have a formal course, but I think probably I've been through every one of these features and had dashboards built within just a few months of joining here, because they're so similar to other programming languages. And for people who aren't programming, the nice thing about that is the RStudio interface does allow you to do a lot of the filtering and manipulation right there in RStudio, so you can see what you're producing. You're not having to wait to run that code out at the end of the program, so you can actually highlight sections of code and step through it. So that's a nice feature if you are using RStudio or Visual Studio. If you're using Microsoft Visual Studio, you can step through your code, which allows you to learn how things are going. But within 3 or 4 months if you come off of SAS, I think you'll be fully up to speed very quickly. And within 3 or 4 months, you can probably have all of these things built that you need going forward.
Well, great, Eric. That looks like all the questions that we had. So I think that if anybody else has a last-minute question. At this point, though, we'd like to thank you for attending the webinar. Before you go, we'd like to invite you to our next networking event and presentation that Emanate will be having on March 20th. There'll be a time to mix and mingle, and Tom Decker and Alex Vardy will be presenting the centralized monitoring and the role of process technology. You can look for an email that is registration information regarding this event and learn more and register for this at www.emanatelifesciences.com. We also need speakers and volunteers. So if you're an expert on one of our upcoming topics and you'd like to volunteer at Emanate event, please contact us. Thanks again for joining us. Thank you, Eric, for your presentation, and have a great day.
Thank you, everyone.